Yeah, so Gajinder and I are working on the Zim client, which is a Zig Beam client. Yeah, thanks for making it, Gajinder. It was quite difficult indeed. And so as part of this work, there are basically two components. You have the client that with the network connection, producing blocks, downloading blocks, and you also have the proving side, which is about running a guest client inside the EVM. And this we wrote our own guest program, and this is what I'm going to talk about during this presentation. As a disclaimer, I had a presentation about this a very similar topic at Protocolberg two weeks ago. So I learned that the video was published yesterday. So if you watched it, there's going to be a bit of a redundancy, but there's still some new stuff. So yeah, what is the guest program about? Well, the structure is very simple. You have if you want, the business logic, the state transition function. And you have the runtime, which is where I guess the most interesting part of this talk will be about. And then you have the ZKVM, which is the one thing that executes the program and will take samples, build a polynomial, do all the fancy proving stuff. But yeah, like the biggest challenge is to build a state transition function program as an ELF that runs into the ZKVM. And what you have to understand is that those ZKVMs, except RE0, I love what you guys are doing, is very much like an embedded target, which means that many languages will not be able to really work into this unless they have some kind of Linux simulation layer. Once again, good job, RE0. So you have to basically emulate the OS and the libc. And this is what the runtime is doing. So, in order to build a guest program, you only have, or you really have two options. Either you take the stock SDK that is provided to you by the ZKVM, which is typically written in Rust, and you also have the Rust runtime. If you want to use a different language like Zig, you can build your own STF, but still somehow link to the Rust runtime, which can be challenging, especially when it's not really available. So sorry for saying that again, but RE0 does it right. Everybody else that I interacted with does not. So yeah, basically, if you want to use a different language right now, your only option is to also rewrite the runtime, and this is what we did. I think for the short term, or at least we see our mission also to evaluate how good those ZKVMs really are in terms of programmer experience. So for us, it's a no-brainer. We have to do the Zig runtime. We have more control. We also have a more streamlined process where we just write an independent STF, and then we have ZKVM specific code. But yeah, that's the burden we're taking. And the reason why we bother with all this is to provide, there's many reasons really, but I would say the most consensual one is runtime diversity. We want to show, if we're proving a runtime, like a single runtime, and there are bugs in it, you're proving the bugs. So being able to find issues, and we are finding a lot of issues, it's quite useful to take a slightly different path to get there. So I'm going to go summarize the program flow. We have once again the state transition function, which is code that we write once, and then we have this ZKVM specific code in yellow, which is, like I said, the interesting part of having this. We don't have to write an abstraction layer. We just have our specific code. We swap it, and we can build many programs in one go. So yeah, the idea is that the program starts in the boot code, it does the initialization, it gets to the state transition function, then it gets the input, which typically will be a block that you want to prove from the state and things like this, goes back to the state transition function, does a lot of syscalls like hashing, for example, or committing to values, and then does more thing in the state transition function. And finally, I should have said halt instead of exit. It calls the last system call and the program terminates. what do we cover so far? So that's one of the things that is different from Protocol Berg. We have RIS0 support. We are able to prove everything end to end. In Protocol Berg, I used to have CNO. We decided to drop it because it's just not production ready at this time. So we have the code saved for when they have something functional, but currently it's just not worth our time. We have Powder, we have the guest program, we have the prover. There's a lot of issues with the verifier, so I started working on fixing this in Powder. And Powder announced that they were discontinuing their RIS5 VM, so this line is going to drop very soon. And then we started looking into ZISC, and the interest of ZISC, I mean, we're especially interested in ZISC because it's a RIS564 target, which is also, I'm also looking into building Geth for a ZKVM target. So it's quite interesting to have a RIS564 target because Geth will not compile to a RIS32 target. SP1 we also started, but communication is a bit slow there, so currently it's on the kind of the back burner. And then we have the three remaining ZKVMs we want to look at. OpenVM, simply because we hope we can reuse some of the Powder code to put it in there. So Powder wants to become integrated into ZKVMs, into OpenVM. So hopefully the work will be fast on this front. And then there's ZK-MIPS. The only reason is also because it's a new architecture, and I'm also in the back of my mind, I have how am I going to compile Geth as a guest client, so that's also a way to investigate this. And then there's Powder is maintaining their WASM VM, so we want to look into this afterwards. So I was saying, when we want to build the ZKVMs, we build all the guest programs in one go, and here you can see, maybe if I explain here, we have some Rust glue, and I'm going to explain what this is later, but we first build the Rust glue to connect to the ZKVM, so here we have Powder and RIS0, and then we build the ZKVM, the guest program, so we build them all in one go, and it's all the same state transition function. We just changed the tiny glue that is there to connect to the ZKVM, so we can basically have a future where we have a multi-prover. We receive one block, we do all the proving with all the ZKVMs, and then we can produce those blocks. So what does the client look like? Well, I forgot the legend again. In yellow you've got what's written in Zig, and in orange you've got what's written in Rust. And so you have the classic client code, so the networking, the state management, you receive the block, you do the tree computation, the hashing, everything. And then when you need to do the proving, you have to go through a Rust glue into the ZKVM prover that will kickstart the runtime, execute the state transition function, come back with the proof. This goes over the network, and then it comes back in another client into over the Rust glue to the verifier. And I think what would really improve is if we could come up with a standard interface. So we had a discussion about this at the Interop in Berlin 2 weeks ago. Basically writing this glue and the runtime is a lot of duplicated code. And in the case of Rust, it's even worse because Rust is a compiler. I mean, so is Zig, to be fair, but we don't have this problem directly. But when we have to build some Rust glue, each ZKVM has their requirement for a version of the compiler. So currently we're quite fine, but I assume that when we start supporting provers in many ZKVMs, we're going to have an issue of compiling every glue bit with a different version of the compiler. So this is something that would be extremely useful to have. Verification libs that are either in C or Go or Java, why not? So that every client could just not have this problem of building some Rust glue with many different compilers. Otherwise, yeah, what ReZero did provide a runtime lib that you can link into a C program would be awesome, and yeah, that's pretty much it. So yeah, I don't have any numbers yet because it makes no sense. Like, we don't really have a spec, a finalized spec, so we didn't really want to benchmark the execution itself. It makes no sense because we don't know what we're doing in terms of business logic. But yeah, for example, for Powder, it takes about 4 seconds to do like just update the state and recompute the tree. So if you're interested in numbers, I can always run the program and tell you how much it takes, but this is not. I think this is not the right time to provide the numbers. Yeah, that's pretty much it.
How complex is the runtime?
The runtime is, I mean, conceptually very simple. In principle, it's like the devil is in the details. Excuse me. So, what's complex is figuring out what ZKVM does under the hood. So you have to go and read the Rust code and realize, oh, this VM does it this way, but this other VM does it the other way. Yeah. So the runtime itself is not complex. It's just maintaining multiple versions of it. Lunchtime.